Black holes hold a mysterious power that not only consumes everything in sight but also traps us. They're like cosmic vacuum cleaners, sucking up everything in their path with an irresistible gravitational force. But what lies beyond their event horizon? That's a question that has plagued scientists and space enthusiasts alike for decades. We know so much about them, yet so little at the same time. Some speculate that black holes could be gateways to other dimensions, while others believe they hold the key to unlocking the secrets of time travel. We all have so many questions about them and can't wait to find out more. But now, after decades of research and experiments, scientists finally see what's inside black hole. It's like a door to another universe was opened for them, and we get to go along for the ride. So what have the intrepid researchers discovered? What is behind this enigmatic and mysterious shroud? Is it as scary as we've been made to believe, or is something entirely different? Let's find out. Imagine a region in space so mysterious that not even light dares to escape its grasp. It's a place where gravity reigns supreme and where black holes reside. These dark entities were first theorized by an English cleric and amateur scientist named John Michell in 1783. He was contemplating how to determine the mass of a star when the idea of black holes hit him like a ton of bricks. He believed that if light consists of small material particles and the star's gravitational pull slows down the particles' speed, it might be possible to calculate the star's mass. But then Michel asked himself a daring question. What if a star's gravity was so strong that its escape velocity exceeded the speed of light? Could light fall back to the surface? Michel calculated that the escape velocity would exceed the speed of light on a star more than 500 times the size of the Sun, making the star invisible to the outside world. Michel was on the right track, but his theory had a flaw. Einstein's theory of relativity showed that light moves through space at a constant speed, regardless of the local strength of gravity. But Michel was correct in pointing out that any object must be invisible if its escape velocity exceeds the speed of light. He was ahead of his time, and his theory made little impression. But the idea of black holes wasn't forgotten. In 1916, Karl Schwarzschild unlocked a mind-boggling discovery, solving Einstein's equations for the existence of a black hole. He envisioned it as a spherical volume of warped space surrounding a concentrated mass, completely invisible to the outside world. But that was just the beginning of this cosmic enigma. The mysterious object was later explored by Robert Oppenheimer and others, who theorized that it could be formed by the collapse of a massive star. Now you must be wondering, what exactly is a black hole? It's not just a point of no return where everything gets sucked in, never to return. There's more to it than that. Picture this: a star with at least 3 times the mass of our Sun collapsing under its own gravity. That's how a black hole is formed. A small, dense area in space where gravity is so strong that even light cannot escape. That's what we call the event horizon. But wait, there's more. Black holes come in different shapes and sizes, and each one is more mysterious than the other. First up, we have stellar mass black holes. Don't let their size fool you. They're tiny but powerful. Born from the violent explosion of a large star, they leave behind a single, incredibly dense black hole. Next up, we have supermassive black holes. These cosmic monsters sit at the center of galaxies with masses ranging from millions to billions of times that of our Sun. They're like cosmic vacuums, gobbling up anything that comes their way. Think of it like this: they can swallow objects 10 times larger than Earth. And then there's the mysterious intermediate mass black holes, IMBHs, the cosmic enigma that has baffled space lovers for years. Their massive sizes, ranging from 100 to 100,000 times that of our Sun, leave us wondering, how did they get so big? Some scientists speculate that they grew by merging with other black holes, like a cosmic game of Pac-Man, while others suggest they may have formed by merging with smaller black holes. However, we don't know much about them yet, but it's more likely that they may have formed by merging with smaller black holes and could eventually become supermassive black holes themselves. Black holes aren't just fascinating because of their mysterious nature. They also represent an exciting new frontier in the field of physics, providing experts with a testing ground for fundamental theories that explain how the universe works. Thanks to Einstein's theory of general relativity, we know that matter distorts time and space, creating the force we call gravity. And because of their immense gravity, black holes can warp space-time, creating a region where time flows differently than in the rest of the universe. This has led some scientists to suggest that black holes could be portals to other universes, or even gateways to the past and future. But despite our fascination with these cosmic phenomena, we still have much to learn about them. For example, Einstein's theory of general relativity has created a common misconception that black holes are holes in the fabric of space-time. In reality, black holes could be even more mind-bending than we previously thought. A recent study published in the journal PRX Quantum proposed that the entire universe could be a hologram, and that black holes may hold the key to understanding this theory. Enrico Rinaldi, a research scientist in the Department of Physics, explained, "In Einstein's general relativity theory, there are no particles, there's just space-time. And in the standard model of particle physics, there's no gravity, there's just particles. Connecting the two different theories is a long-standing issue in physics, something people have been trying to do since the last century. But how can it be done?" Enrico and his team have taken a quantum approach to finding the answer. They used quantum matrix models to probe holographic duality, connecting the mathematics of gravity and particles. But finding the ground state, the point where everything comes together and it all makes sense, is quite a difficult task. This ground state could be viewed as a sort of hologram, and maybe the missing link between Einstein's theory of gravity and particles. It's like finding a needle in a haystack. To solve this, the researchers used a framework made of blocks of numbers, commonly used in quantum computers, to represent particle theory by one-dimensional strings. Enrico explains that this ground state is like knowing the material, whether it's a conductor or a superconductor, or if it's strong or weak. The numbers in the matrix models are like grains of sand, and just like sand, they can ripple and shift. But how do you level them out? It's a challenge faced by scientists working with quantum computers. These computers use algorithms to find the ground state, or lowest energy state of a system. But there's another way to approach the problem: using neural networks, a type of AI technique inspired by the human brain. It's like a musical performance, with each qubit serving as a wire carrying precious quantum information. The quantum gates, which dictate how information flows, add drama to the symphony of data. But can deep learning, another type of machine learning, compete with the power of quantum circuits? The researchers set out to compare the two methods, wondering which one would reign supreme. Enrico's team defined the mathematical description of the quantum state of their matrix model, then used a special neural network to find the matrix's ground state. Think of it like leveling a bucket of sand, grain by grain until it's all flat. Both methods found the ground state, but quantum circuits have a small number of qubits. Adding more lines to the music sheet is expensive and less precise. Despite this limitation, the researchers were able to gain a deeper understanding of black holes through their study. The matrix models they examined held the key to unlocking the mysteries of black holes. But just when scientists thought they had a handle on what lay beyond the event horizon, a new and baffling phenomenon emerged. Recently, Duncan Farah and his colleagues had published two groundbreaking papers that shook the scientific community to its core. They discovered that black holes could gain mass, even when there was nothing for them to feed on. This peculiar habit could help solve the mystery of dark energy, the force that defies gravity and pushes our universe to expand faster than ever before. Farah measured the mass of black holes in giant elliptical galaxies, where new stars are not created, and there is no material for the supermassive black holes to consume. But to their surprise, the black holes kept growing long after they should have stopped. As they compared distant giant elliptical galaxies to nearby ones, they found that the black holes grew at the same rate as the universe expanded over time, suggesting that black holes could be the key to unlocking the secrets of dark energy. However, the current model of black holes suggests that their centers collapse into a singularity, a mathematical impossibility. What happens to the physics inside a black hole when it gets weird? Well, according to Farah and his colleagues, strange things happen and physics gets even weirder. Picture a rubber band being stretched along with the universe as it expands, just like a coupled black hole. As it stretches, its energy increases, and the black hole's mass increases too. But that new mass creates pressure which pushes the universe to expand even more. It's fascinating to think that coupled black holes might contain something called vacuum energy, a form of dark energy. This theory provides a new piece of evidence for the idea, but there's still a long way to go before we definitely understand black holes and dark energy. As we explore the mysteries of the universe, we're reminded that even when we think we know everything, there's still so much more to learn. Who knows what other incredible discoveries await us? Could there be more to black holes than we ever imagined? The possibilities are endless, and the answers lie out there, waiting to be discovered.